Hello students, welcome. In this session, we are going to analyze the JEE Mains 2022 physics papers from the June attempt. And it is my sincere hope that the analysis will help you to prepare smarter for the upcoming attempt in July. And remember that you still have 2 weeks. You can make improvement, whether it is of 10 marks, 20 marks, 30 marks, you can make that improvement and get that desired percentile. But you have to prepare smart. You have to know where to focus. So hopefully this analysis, this video will give you the tips of where to focus. Okay, let's start with the most interesting thing. There were 8 types of questions, only 8 types of questions which appeared 50 times in these 12 papers. So what are those question types? We'll talk about them in just a moment, but let's first go through the different chapters and see how many questions we got from each chapter. Units and dimensions, we got 1 to 2 questions. Kinematics, 2 questions. Force and motion, 1 question. Work energy power, 0 to 1 question. Center of mass and linear momentum, 0 to 1 question. Rotation, 1 to 2 questions. Gravitation, 1 question. Fluids and elasticity, 1 to 2 questions. Simple harmonic motion, 0 to 1 question. Waves, 0 to 1. Heat and thermodynamics, 3 questions. Electrostatics, 2 to 3 questions. Current and electricity, 2 to 3 questions. Magnetics, 1 to 2 questions. Induction and AC, 2 to 3 questions. Optics and EM waves, 3 questions. Modern physics, semiconductors and communications, 5 questions. So nothing much has changed really from the previous year. More or less, maybe a few questions here and there, but largely the distribution by chapter has remained the same as before. So now let's get into the interesting stuff. So what are those 8 types of questions which showed up so many times? How many times? 50 times, which means that every student who appeared in the June, they should have seen 3 to 4 questions out of these 8 types of questions. So let's go through them. LCR series circuit with AC source. There were 9 questions from here. 2 of them involved resonance condition, that is XL is equals to XC, that is the reactance of the inductor was equal to the reactance of the capacitor. AM modulation, there were 7 questions around the concept of AM modulation. Viscosity, there were 6 questions around viscosity. Carnot engine, 6 questions. Photoelectric effect, 6 questions. Dimensions of known physical quantities, 5 questions. Circular motion in uniform magnetic field, and you were asked to find the radius of curvature. There were 5 such questions. Projectile motion, also there were 5 questions, which was interesting. In 2021, we didn't see any question at all from projectile motion, but this year we saw 5 questions only in the June attempt. So use these as your reference as you are preparing for your July attempt. So make sure that you learn about these 8 types of questions well, master them, practice the previous year's questions on these concepts. Okay, and before we go ahead and talk about the important questions from each chapter, note that I have been saying this earlier as well to our students, that focus on these important question types. There is no point in reading physics in the entirety. That will take too much time. You need to know where questions are coming from, where to focus. So it is my sincere hope that you will take this advice and focus where it matters. Okay. So we're going to cover 71 different types of questions from every chapter in total, right? In total, we're going to talk about 71 types of questions from where you can expect 70 marks. So this is not that difficult to master. It is very specific. Okay, so let's start. Units and dimensions. 4 types of questions that you should focus. Number 1, finding dimensions of the known physical quantities. Number 2, given an equation, you will be asked to find the dimensions of the unknown. Number 3, finding error in the calculated value, given the error in the measured value. Number 4, questions around vernier caliper and screw gauge. This time we saw questions on the basics of vernier caliper, that is finding the least count given the information about number of main scale divisions that coincide with number of divisions of the vernier scale. Moving on to kinematics. So I'll talk about 5 different types of questions that you want to focus at. Projectile motion. Number 2, one-dimensional motion, particle under constant acceleration, no change in direction, no complexity, fairly simple and straightforward. Next one, 1D motion with change in direction. For example, you threw the particle vertically upwards, so the particle is going to stop at some point and then come back. So it will be changing the direction of motion. Next one, wherein particle will be moving in the same direction, but it will have 2 different segments with different accelerations. So you will have to use the standard kinematic equations, s is equals to ut plus half at square and v is equals to u plus at to determine the unknown for these 3 question types. Now in the next one, you will be asked to find the angle between the given vectors, or given some information about the vectors, you will be asked to find the angle between them. Moving on to force and motion. So I'll talk about 5 different types of questions in force and motion that you might want to focus at. The first one is the uniform circular motion in horizontal plane. So herein a particle will be moving in a circular path in the horizontal plane, and you will have to use F is equals to ma, that is the centripetal force is equals to mass times v square by r to determine the unknown. Next one, wherein masses are moving together and you will have to determine the internal or the contact force between the masses, and from there you will have to answer or find the whatever unknown the question is asking for. Next one, wherein you will be given that a particle or an extended rigid body is in equilibrium and there are no frictional forces involved. So you'll have to use summation of all the forces in x and y direction is 0, and summation of all the torques about say the z axis are 0. Next one, here you will be given an extended rigid body, say a ladder, placed against the wall, and you will have friction forces involved as well, and once again you will have to use the same equations to determine the unknown. And the next one, which showed up this year but has not showed up in the previous years, are the questions on the mass pulley arrangement, right? The mass pulley arrangement. Now moving on to the work energy power. So one question that you might want to focus at is the scenario wherein a particle is descending vertically and you will have the gravitational potential energy converted into the kinetic energy. So you will have to use the conservation of mechanical energy to determine the unknown. Moving on to the center of mass and linear momentum. So here this time there were a few questions involving scenarios where either the mass was breaking apart, say exploding into multiple pieces, or you were given a scenarios where masses were coming together. So the man was jumping on the trolley. So here you need to apply the conservation of linear momentum in say the horizontal direction or any other direction where the net forces are 0 or net external forces are 0 on the system. In rotation, 2 types of questions you might want to focus on based on the question that showed up in the June attempt are moment of inertia of standard object, system of particles. Make sure that you are well versed, that you are comfortable, or that you know the moment of inertia for disk, about the diameter, about the central axis or the ring or the sphere or the hollow sphere, and so on. Next one is scenarios involving the rotational kinematics. That is, a particle is moving along a circular path with the angular acceleration, and you'll have to determine some unknown using the standard kinematic equation for the rotational motion. That is, omega is equals to omega 0 plus alpha t, and delta theta is equals to omega 0 t plus half alpha t squared. Moving on to gravitation. 2 types of questions you want to focus on is number 1, gravitational acceleration or the force due to a uniform spherical body at some point at certain height from the surface or at a certain depth from the surface. Fairly standard questions. Next one is scenarios wherein the satellite or the planet is moving in a circular orbit, and you will have to use the information around the time period, that is the time it takes for the object to make one complete revolution, to determine the unknown. Moving on to fluids and elasticity, 3 questions that you might want to pay attention is: number 1, viscosity, questions on viscosity; number 2, questions involving Bernoulli's equation and equation of continuity; and in the elasticity, tensile stress is equals to Young's modulus times strain. This time viscosity was quite a bit of, saw a lot of focus compared to previous years, something I mentioned earlier as well. Moving on to simple harmonic motion. Focus on the basics of the simple harmonic motion and use them to find the unknown. Next one, you'll be given the expression for the simple harmonic motion. So that means you'll be given either the x versus t graph, or you will be given x is equals to a sine of omega t plus phi, and you will have to determine the either the particle speed at certain time or some other information using the given information here. In waves, we saw a couple of questions on resonance and then a couple of questions on number of beats per second. Heat and thermodynamics. So here I'll talk about 9 different types of questions that you should be comfortable with. Number 1, Carnot heat engine. Make sure that you are pretty comfortable with the efficiency, use of the fact that the entropy, net entropy change is 0 for the complete cycle, and the fact that the net work done is QH minus QL. So in the next one, given a thermodynamic process, you'll be asked to find either the heat released or heat absorbed, change in internal energy, work done, or molar heat capacity for some standard or non-standard thermodynamic process. In the next one, you will have to use the ideal gas law, PV is equals to nRT, to determine the unknown. Make sure that you practice some of these questions so that you are comfortable with the amount of math involved there. In the next type of question, you will have to use the relation that heat absorbed for a solid or a liquid, heat absorbed is equals to mass times the specific heat times delta T, or average power is Q by T. Moving on, you might be given scenarios wherein you are dealing with change of state of water, and you will have to use the conservation of energy to determine some information about the temperature. So in the next one, given an object and the change in temperature it undergoes, and given its coefficient of linear expansion or volume expansion, you will have to determine the unknown. Now in the following one, you will be given slabs in series, and you will have to find either the equivalent thermal conductivity or the temperature of the interface or the rate of heat transfer. Moving on to the kinetic theory of gases, you should focus on the RMS speed, which is square root of 3 RT by M, and you should make sure that you are comfortable with the CPCB basics. Now moving on to electrostatics, I'll only talk about 2 questions, but of course there were about 28 questions, so we'll have a separate discussion on electrostatics fairly shortly, where Ritesh Sir, another batchmate of mine from IIT Delhi, so we'll be talking about certain topics. Electrostatics will be one of them. So we'll look at questions asked on electrostatic force, different questions asked on electric field, electric potential, capacitors and whatnot. But for now, 2 questions that you want to pay attention to are: number 1, where you are given a charged capacitor which is connected to an uncharged capacitor, and you will have to determine the charge after the switch is closed, charge on the 2 capacitors. Or you might be asked to determine the change in energy, change in potential energy after the 2 are connected. Now in these June papers, you were given certain scenarios wherein you were given the point charge arrangement, and you were asked to determine some information about the electric field due to these point charges. Now moving on to current electricity, there were 4 questions where you were either asked to determine the equivalent resistance, or you had to find the equivalent resistance and then find the current in the circuit, and the circuit given was visually complex, but you just had to use your smarts to simplify the circuit and then find the R equivalent and the resulting current. Now there were a couple of questions involving batteries with internal resistance, and these batteries were either in series or in parallel. So make sure that you're comfortable with batteries in series and parallel, especially parallel. Now there were some questions, fairly simple, straightforward questions where you had to determine the current in certain section of the conductor with circular cross section. Okay. Now moving on, in the next one, you were given a resistance, given a wire, and the wire was stretched, and you were asked to determine the change in the resistance due to the stretching. Moving on, now in these kind of questions you were given certain resistances, and you had to find some information about the maximum and minimum effective resistance. Now on the potentiometer at null, there were a couple of questions, so make sure that you revisit your understanding of the potentiometer. Moving on to magnetics, there were quite a few questions on radius of curvature, finding the radius of curvature of a charged particle moving in uniform magnetic field with its velocity perpendicular to the magnetic field. Then there were some questions involving the magnetic susceptibility and the dip. So another 3-4 types of questions from magnetics were number 3, the basics of motion of a charged particle in the magnetic field. Things such as the magnetic force does not do any work on the charged particle. Right? Now, in the next one, make sure that you are comfortable with the expression, or that you remember the expression for magnetic field of a circular coil at the center or at some point along the axis. As far as the solenoid is concerned, it's mu0 In, and for toroid, you can quickly revisit your equation there. Now, there were some questions on finding the magnetic field inside a long, straight current carrying wire. Hollow wire, solid wire, but finding B inside the straight current carrying wire. There were also a couple of questions on force between the two parallel straight wires. Parallel straight wires. Either you were given a charge between the moving charge between the two parallel wires, and you determine the force on the charge, or you had to determine the force between the two parallel wires, or you had to determine the magnetic field at some point. With that, we're going to move on to the induction and LC oscillations. Here I'll talk about 5 different types of questions that you should pay attention to. Number 1, LCR series circuit with AC source. LCR series circuit with AC source, which we have already spoken about. Now in the next one, there were a couple of questions wherein you had a rod or a wire either rotating inside a uniform external field or moving through the external field, and you had to determine the induced EMF between the two ends. Now in the next one, which is involving an AC source and either a resistive circuit or purely inductive circuit or purely capacitive circuit, you had to determine the unknown. Now in the next one, given the expression for I, you had to determine the time at which the current reaches a certain value. So make sure you revisit your concepts on the alternating current. Now moving on to optics and EM waves. So let me start with the EM waves. As always, focus on the basics of the EM waves, right? So what is the expression for the speed of the EM wave? What is the relation between the electric and the magnetic vector and your direction of propagation? So make sure that you revisit your fundamentals, and you should be okay there. Now there were also a couple of questions on the involving the intensity, understanding of intensity of a traveling wave. EM spectrum. There were 3 questions, just testing your basic understanding of the different aspects of the EM spectrum. Now in some questions you were given the interference between waves of different intensities. So you were given the intensities and you were asked to determine the maximum and the minimum intensity. Now in some question you were given the electric field vector and the direction of propagation, and you were asked to find the magnetic field or vice versa. And there were some questions on the magnetism of matter. And now moving on to the optics, there were a couple of questions on the basics of refraction of light. Then there were some questions requiring you to use the Snell's law to determine the unknown. And then you had a couple of scenarios involving the total internal reflection. pretty fairly standard stuff that we have seen over the last few years. Now, as far as the Young's double slit experiment, fringe width, as always, is the focus. And there were some questions involving either a medium instead of a vacuum between the slits and the screen, or you had a glass slab placed in front of one of these slits, and then you were asked some information about the interference pattern. With that, now let's move to the modern physics, semiconductors, and communication. Now, I seriously hope that this has not been an overwhelming discussion, but the whole idea is that you listen through this video. If you have to listen it multiple times, listen through it multiple times, but that you get a gist of what are the important focus areas that you should make sure that you nail them down, that you get them right. Okay, so here I'm not going to segregate modern physics, semiconductors, and communication. Rather, I'll keep them together. So air modulation, we've already talked. The photoelectric effect, we have already spoken about. De Broglie wavelength of the subatomic particle. Last year, there was a lot of questions. There were a lot of questions from de Broglie. This year also, there are quite a few questions, if not as many, but there are still quite a few questions from de Broglie wavelength. Then there were, again, quite a few questions on the radioactive decay, transistor and the common emitter configuration, questions testing your basics of the nuclear physics. That is, during the nuclear reaction, the mass is conserved, the charge is conserved, the momentum is conserved. Then there were a couple of questions on the basics of diodes or the PN junctions. Now, again, there were a couple of questions on the basic of communication. And then you had a couple of questions wherein you had the electron in the hydrogen or hydrogen-like atom jump from one orbit or the other. As a result, you had a photon emitted or photon absorbed, depending on which way the transition is happening, and you had to use that information to determine the unknown. Then there were a couple of questions on the modern physics basics, and then you had a couple of questions on the ideal and silicon diodes in a circuit, and there are also a couple of questions on Zener diodes in circuit. And this time, lesser number of questions on combination of gates, but still make sure that you pay good attention to that. And then there were a couple of questions on line of sight communication, simple questions. And that's the gist of important or focus areas by the examiners in the JEE Main 2022 June attempt. So use this information to prepare smarter in the next 2 weeks. And always, as always, I mention, if you want to focus a little bit broader so that you're not surprised, make sure that you go through, again, those 137 question types. This time they got you almost 80 marks if you had done them right. Okay, so instead of focusing on 700 or 800 different concepts that there are in physics, you just need to focus for JEE Mains, you just need to focus on 137. So with that, best wishes, prepare smart, and you can do well. You can score higher. Okay, all the best for your upcoming exam and your preparation. Thank you.